Now let's talk about Grignard reagent RMGX with cyanide RC triple bond N. So RC triple bond N when react with CH3 MgCl which is in excess, second H plus H2. So it will form RC double bond O CH3. Now what will happen? Majorly this compound will form. Now what will happen? First of the step CH3 minus we have, it will react with RC triple bond N. And we know as we know further that RC triple bond N react. So when we know that it will attack on carbon and nitrogen, the lone it will go here. RCCH3 double bond N negative. It will react with H plus, then it will form RC double bond NH, then CH3. Now on hydrolysis it will form HOH, HOH. So it will form amine will release, and it will form RC OH, OH, CH3 plus amine will go, ammonia gas will go, and there the two OH minus generally are not stable on a carbon. So minus hydrogen will also go, H2O, water will go, and it will form ketone. So it does form ketone. So let's look some problems regarding this question. First we have CH3 triple bond and react with first PH MgCl, second H plus H2O. Second we have PH C triple bond N. It will react with ET MgCl, second H plus H2O. Third we have C triple bond N. It will react with PH MgCl, second H plus H2O. Fourth we have hydrogen cyanide react with EtMgCl, second H plus H2O. Try the question by your own, pause the video and try to answer by your own. So the answer in first is CH3 C double bond O PH, second is PH C double bond O ET, third is C double bond O BH, and fourth is ETH plus Mg Cl and Cn. So in fourth actually this Et minus will abstract the hydrogen, Cn minus will go with magnesium. Now let's talk about reaction of Grignard reagent with epoxide. RMGX with epoxide. RMG is how it will react with epoxide. We have CH2, CH2O, and one we have PH MgCl, second H plus H2O. It will form PH CH2 CH2OH. Now look at its mechanism. First we have PH minus reacting with CH2 then O. It will attack over here, the bond will flip back, it will form CH2 PH CH2OH. Now let's talk about another. If we would have CH3 CH CH2 and O, let's say example we have this. So it will react with PH MgCl, second H plus H2O. So it could attack on this side also and this side, let's say A and this is B. So it can attack on through the path A also, through the path B also. But it is easy to attack through the path B because of this methyl group will provide the steric hindrance. Hence it will not prefer to go by this. So it will form CH3 CH O minus CH2 BH. Now let's say we have a compound, this epoxide will react with RMgCl, or this will react with RMgCl. And this also react with RMgCl. Second, H plus H2. And fourth we have hydrogen, CH3MgCl, second H plus H2. So how does it forms? First, it will not react because it is ring is very stable, that it will not open when this R react with here. Similarly, in second case also the ring will not open, but in third case the ring will open. Up to the second or third case the ring opens, up to 2-membered, 3-membered or 4-member ring open. That is a lot strain, but 5-member and 6-member doesn't have that much strain, so the ring will not open. So R minus will attack over here, this ring will open, so it will form OH R. And fifth also the CH3 will attack over here, this ring will open, it will form HOH CH3H, and its mirror image. CH3H HOH. They are enantiomer. Now similarly, let's solve some problems regarding epoxide. First we have CH3 MgCl, second H plus H2, PHCH, first ETMgCl, second H plus H2, third CH3MgCl, second H plus H2. So how does it react? It's first CH3 minus will attack where it has less steric hindrance, so it will form OH CH2 and CH3. Second also ET minus will attack where less steric hindrance, PH CH2 OH CH2 ET. Third, CH3 minus will attack over here, the ring will open like this, OH CH2 CH3. Now let's talk about a couple of more problems. Fourth, first ETMgCl, H plus H2. Fifth, CH3MgCl, H plus H2. So it will form OH H ethyl, because ET minus will attack over, the ring will flip like this, and we will be having its mirror image. Not mirror image, OH H ethyl. We have done some mistake in previous problem, like it's fine. CH3MgCl. Now in this problem, the CH3 minus could attack from the both side, so it will form CH3H MEOH. MEH OH ME. So it will form like this. Now let's look one more problem with reaction with oxygen. How does Grignard reagent react with oxygen? So Grignard reagent, we have 2RMgCl react with first oxygen, second H plus H2O. It will form 2ROH plus 2MgCl and OH. What is the mechanism does it follow? First of all, we have R minus plus. So it will attack over here. This bond will go here. Now we have second RO negative. That R negative also attacks. R negative also attacks on this oxygen, and it forms RO minus plus RO minus. Then both react with H plus and form ROH and ROH. So alcohol will form. So in that case, alcohol will form. Now let's look some problems regarding number of moles of Grignard reagent per mole of given compound. First we have N triple bond C. So 1 mole of Grignard reagent will react 3 moles of this. 1 mole here, 1 mole here. It will react 3 moles. And 1 mole with OH. So I am writing the question and try to answer by your own. Fifth, so it will react with 3 moles of this, 2 moles of this, and 3 moles of this. So that's how we solve this problem.